Welcome all. I especially mention every scientist and researcher in this conference, third international conference on big data and machine learning BML-22. And thank you for accepting my abstract for oral presentation for presenting in this great event entitled Construction a Sustainable and Smart Container Storage Strategy. This work presented from Mohammed Saleh and in partnership with Hatem, Computer Science and System Engineering, Faculty Science Abdelmalek Essaâdi University, Tetouan, Morocco. With the development in transportation operations, the use of international multimodal transportation with modern technology, the application of electronic data interchange and on-time delivery service. All these factors impose the necessity of building integrated sustainable strategy. Therefore, in this abstract, we propose to build sustainable strategy based on strings of 3D matrix and smart manipulation for container stacking, using the latest methodologies and tools, which matches different port size based on the assumption of time dynamics to choose the optimal location of the container in the terminal yard. The effectiveness of this strategy depends on smart sustainability solution, which will improve the performance of other related systems serving the yard, such as crane system, gate system, berthing system, and etc. The overall objective of solving the problem by creating a strategic, sustainable, and integrated solution is to enable port operators, both governmental and private, to optimize the stacking of incoming containers in chronological order for retrieval without doing modification as possible, taking into account a set of transactions including the destination port and carrier as well as the rest of the transaction, such as reducing container storage time, resulting in more efficient staking extracting operations, as well as reducing containers dwell time. The problematic. There is a problem when stacking and extracting incoming containers, and the inability to take the appropriate decision to choose the optimal place for new containers. The aspect of the problem, random staking and increased operational cost and time, the difficulty of investing in the infrastructure, absence of informed decision making in real staking, extracting, absence of an effective methodology for applying artificial intelligence. How was the problem resolved? Based on our previous studying, we suggested a hypothesis of double chronic. We called it a paired bay, and arranged the location of the containers in the terminal yard according to the time of departure, as if each slot in the container is defined by date and time, and thus begin the storage processing of containers according to the containers that are furthest time, working with data and using artificial intelligence algorithms. This image explains our previous hypothesis. It's called Paired Bay. We divided the block of the terminal yard to Paired Bay. Paired Bay is the division of bays into two bays together. Chronicle bay suggests a method for linking the bay with a specific date and time. This image explains our idea. We deal with all aspects of information at the yard as matrix, and we are trying to apply artificial intelligence in case we get the proper required data. The strategy achieved some features. The strategy adopts a new approach to improving performance and enhance competitiveness and commensurate with the vision of implementing the port system reform. And this enables it to create an added value for the actors in the port sector, enhance competitiveness in the economy, and achieve development for various parties through improving the port's logistic performance. It takes into account the challenges of the era, such as the development of transportation, technological progress, and linking sub-solutions for the active system in the port. The active of the activate of environment systems. It is compatible with the general structure of all type of ports, as it does not require a new structure designed for the port. Outcomes and benefits of this strategy: speed of reception, speed of staking and extracting, minimize arranging and rearranging operations, rationalizing the movement of equipments and efficiency in use, orientation towards achieving the following: integration, whether between internal or with external ports, with the possibility of adapting to changes that will occur in the future. Intelligence, smart, sustainable growth by using artificial intelligence algorithms to improve the various operations in the port. Improving the staking operation is integrated with the berth system of ships, the gate system for trucks, etc. Competitiveness. Conclusion: in the face of the challenges of the 21st century, this strategy provides a special, broader dynamism that helps demonstrate smart, sustainable, and inclusive growth. This creates a circular economy that combines economic growth and the preservation of natural heritage through new pattern of storage and extracting. This strategy also opens horizons for researchers, port operators, countries, and organizations with governments or private companies to think about modern paths to the issue of unifying structure and procedures that demonstrating the economic weight of the ports and the possibility of linking them each other through a different supply chain. Thank you for your attention.